Ma'am, I'll go ahead and welcome everybody and introduce the session.
Yes, please. Yes, please, Anna. Please go ahead.
All right. So, good morning, everyone, and welcome to the International Workshop on Digital Humanities Theory and Praxis. Today is the fourth day, and we are delighted to have our student scholars, the head of the department, Nishad Zari ma'am, and Professor Saini with us. Very warm welcome to all of you, and a very good morning. We have had a very wonderful session yesterday with Professor Saini talking about prosody, poetry, and various terms that we need to be aware of with NLP and digital humanities. So, and we have another session today again, which is titled "A Meeting Between Artificial Intelligence and Punjabi Poetry." Um, and thank you so much, Professor Sani, for being with us. And very, very thankful to you for your session yesterday, and really looking forward to today's as well. So over to you. Please start. Thank you.
Yeah, I am sharing my presentation. Just a moment.
Yeah, sure. And we have the moderators, Asra and Zahra, in case any, if you need anything, they'll be online. We'll all be online with you. So please feel free to ask if you need anything.
Yeah. Is my screen visible?
Yes, sir.
Okay.
Very much. Yeah.
So a very good morning to all. So today I will be discussing about a meeting between artificial intelligence, which is generally abbreviated as AI, and Punjabi poetry. And on the sidelines, let me also tell you that whatever I am sharing here is not something which is just necessarily applicable to Punjabi poetry. For that matter, it can be applied to poetry of any other language, maybe Indian language, maybe some foreign language as well. So because I will be talking about poetry, so I thought that I should share this. And this is not something which is that uncommon. Poetry is ordinary language raised to the nth power. Poetry is wound with ideas, nerved and blooded with emotions, all held together by the delicate, tough skin of words. This is a very famous quote, in fact, from Paul. So, as far as English poetry is concerned, I think hardly there will be any person who has not heard of Paul's name, or who has not heard of this very, very famous quote. मतलब अगर मुझे ऐसा बोलना हो तो मैं बोल सकता हूँ कि जिसने राहत इंदौरी या शून्य पानपुरी या जलन मातरी जैसे लोगों का नाम नहीं सुना है उसने इंग्लिश पोइट्री में पॉल का नाम नहीं सुना होगा. So this was, just to give you the touch that when we talk about poetry, we need to talk about sentiments, we need to talk about emotions, we need to think in some other terms which we conventionally don't do when we talk about prose and when we talk about stories. So this is a brief introduction about me. Yesterday already quite a detailed discussion was given by Dr. Gupta, so I will not be going in details. I completed one thing definitely that I would like to highlight is because it seems that all of you, or at least majority of you, are people from the domain of linguistics. So one thing that I would like to emphasize is that I am basically a person from the field of computer science with BSc Computer Science with silver medal, and MCA I was university topper in all 3 years and received the gold medal, and then completed PhD in the year 2009. Now that is a coincidence that my area of research had the overlap of both of these fields, the languages as well as the computer science, and perfectly well that is where digital humanities and the theme of this workshop comes into picture. So I will not be going in detail as far as my introduction is concerned. So a disclaimer from my side that whatever I will be discussing in this presentation, as part of this presentation, it is solely for academic and research purposes only. It is not meant to hurt anyone's feelings, and I think when I say that it is solely for academic and research purposes only, it covers everything. So directly moving on to the points of discussion. Yesterday also I had discussed some parlance. Now I am not very sure whether the audience that we are having today is the same audience that we were having yesterday. So I will not be going in detail as far as those points are covered, those points are concerned that I had covered yesterday. But definitely I will be just touching on those points so that even if there is someone who has joined new as far as this session is concerned, they will be able to get a glimpse of what we discussed yesterday, as well as it will also, create that platform on which we will be able to construct today's session. So we have some concept of language families. I have discussed it quite in detail yesterday, so I will not be going in details today, except that, so we have language families, we have many of them, and one of them is Indo-European language family, and one of its branches is Indo-Iranian language family, and it has again 3 children. One of them, you have Nuristani, you have Iranian, and then you have Indo-Aryan. So Indo-Aryan languages means the Indic languages, and that will be the area of focus for the today's discussion, because Punjabi language falls in that category. But let me also tell you, as I had said in the beginning, for the first slide also, that whatever we are discussing today as far as the artificial intelligence algorithms are concerned, it is not so that you can just apply them to the Punjabi language. You can apply it to any other language. And then we have the concepts of text and speech when it comes to natural language processing. So today I will be talking about the text part. I will not be touching on the speech part. You know, when you talk about speech, you have to talk about phonetics, you have to talk about acoustics, you have to talk about the speech recognition systems, you have to talk about the speech generation systems, you have to talk about Alexa, you have to talk about Cortana, you have to talk about Siri, and so on and so forth. So that will not be the area of focus today. Today, the focus will be on text. But at the same time, let me also tell you, because I will be talking about poetry. So when you talk about poetry, and if you say that you are not at all touching about the speech, it will not work, because poetry has something to do with rhymes. Poetry has something to do with the rhythm. So as far as that phonemic part is concerned, definitely I will be touching on that part. So that is about text and speech. Moving further, so this was also discussed quite in detail yesterday. So just, to brush up the things. So initially we used to have the Department of Linguistics. Basically, they study the use of languages. Then came the concept of computational linguistics. So with the advent of technology, when the computers came up, the people who were working in the domains of languages, they started to use the computational power for processing the languages. And when I say languages, I am just talking about the natural languages. I am not talking about the artificial languages. So use of computers for processing the languages gives us an area called computational linguistics. And computational linguistics typically used to follow the symbolic approach, where the things were hard-coded, they were rule-based, something of the sort. You have some input, and it is hard-coded that if this is the input, then this will be the output. So it is like, if this, then do this, else do this, else do this, else if do this. So basically, that is the approach which is followed in computational linguistics. It is typically symbolic-based, it is typically rule-based, it is hard-coded, it is transparent, and it inherits from, yesterday I discussed about 2 schools of philosophy. One which was by Noam Chomsky, and in fact he was not the only one, because before him also there were many philosophers in the 16th, 17th, 14th and 15th centuries as well, who talked about the rationalist approach. And then we have another school of philosophy which talks about the empiricist approach. So computational linguistics basically deals with the rationalist approach, and I had discussed in quite a detail yesterday. So for the time being, I am just touching on those terms, that it basically inherits from the rationalist approach. Then we have the concept of artificial intelligence, and as far as the evolution of these techniques is concerned, I mean the evolution of the field of natural language processing and the evolution of the field of artificial intelligence, almost they have gone hand in hand, quite in harmony. Except that natural languages used to exist before also. I mean, if you talk about 1,000 years before, people used to communicate. What is language? Language is something that can be used for communication. So languages used to exist before also, but with the advent of computers, people started to use the computational power for processing the languages. So that was with the computational linguistics. And later on, people thought that why not make computer do all that processing that human beings can do? So basically incorporating the intelligence that human beings have, incorporating that intelligence in the machines. So that led to the concept of artificial intelligence. And if you see the development, particularly from 50s, I mean 1950s and onwards, almost the evolution of the field of artificial intelligence as well as NLP has gone hand in hand. At one point of time, people used to say that AI is NLP and NLP is AI. But later on, they became full-fledged fields in itself. And as on date, if you have to talk about this in 2020, you can say that AI, you will hardly find any field where you will not able to find applications of AI, be it medical domain, be it transportation, be it real estate, anything that you can think of. And NLP has now, as of date, emerged as a branch which has an overlap with the field of AI, and it has focused more on the processing of natural languages. And so that is how the field of natural language processing came into picture. And we had that symbolic approach earlier, and then we had non-symbolic approach. Particularly the period from 1950s to 1980s was quite dominated by the Chomskyan philosophy of rationalist approach. And then from 80s, people started to use the statistical techniques for the processing of languages. I mean, you give a lot of data to the computer, and then instead of hard coding the rules, as used to be done with computational linguistics, now it was the computer using the statistical techniques, it used to come out with the statistical patterns in the given data. So that was in the early 80s. And afterwards, that means towards the beginning of the 21st century, people started to use other approaches like deep learning. Specifically, it is said that rather after the first decade of the 21st century, people started to use the deep learning techniques. And this is what we are using as on date also. And it is not just symbolic and non-symbolic. And when I say symbolic, it includes statistical and deep learning techniques. But as on date, people are using neurosymbolic approaches. So neurosymbolic approaches means we were bringing the best of both of the worlds. The symbolic approach, which was like transparent approach, and the deep learning approaches, which are completely like a black box, because we just give data to your computer and you don't know how the computer is coming out with the patterns. So it is only left just to the computer. So neurosymbolic makes best of both of these two approaches. You have some rules which are hard-coded, and then you are giving data to your computer, and then it comes out with the patterns. So you are using a combination of these two things. So that is about neurosymbolic approaches. And this is about natural language processing. And as I said, that I will be focusing on the text part as far as today's discussion is concerned. So having discussed about the parlance, having built that vocabulary of what we are going to discuss today, now let us come to the specific part, the natural language processing, NLP. It is abbreviated as NLP. Now, this is something that I had discussed yesterday also, so I will not be going in detail in favor of time saving. So natural language processing has two branches: natural language generation, which deals with the generation of natural language. And you can think this in terms of stories and in poems. When it comes to stories, it is difficult because you have to make sure, it is not just generating a language. You have to make sure that there is a coherence, there is a structure, there is a relationship, that discourse is maintained, that context is maintained. So if you have 10 sentences, the first sentence relates with the second sentence and so on. There should be a flow also. Additionally, then you have to take care of those anaphora resolution and other things. So generation of stories is comparatively difficult, whereas when it comes to poetry, it is comparatively easy. And obviously, as I said yesterday also, this is not absolute discussion. This is relative. So for poetry, it is easy because whatever you write, and if you don't tell anyone that this is computer-generated poetry, so anyone will get the impression that this is a computer-generated poetry, and poet has written it that way only. Because there is no restriction on poets. But when it comes to stories, you expect something, that there should be some flow, there should be some grammatical structure, some syntactical structure should be followed, there should be some semantics. But when it comes to poetry, okay, you will say, fine, poet has written it that way, so it's okay, it is acceptable. And yesterday I had included, if I remember, three examples of Hindi auto-generated poetry, two examples of English auto-generated poetry. One was with Bengali, one was with Russian also. So today I will just include one or two of them, and then we will proceed with the rest of the discussion. So other than natural language generation, the other broad area under NLP is natural language understanding, where we try to understand the natural language. And again, for stories, it is easy. The same reasons which are responsible for making it difficult to generate it are responsible for making it easy to understand it, actually. Because you have that typical structure. So this is the word order for a given language. You know that, okay, this is a noun, this is a pronoun. So it makes for the computer to, it makes it easy for the computer to understand it. And for poem, it is a bit difficult, as I said, because See, generating poetry is easy because whatever you generate, anyone will get the impression that, okay, this is the way how the poet has written it. But when it comes to understanding, it becomes difficult because, you have to then take care of the emotions the poet had, the flow the poet had considered, and could be the theme, could be the structure, could be, then there are n number of things. I mean, poets think something else, and when they put it on paper, I will not say that they think something else and then they put on paper something else. It is not so. But they think something else, and the way they put it on paper is a different approach. So in fact, that is what makes it a poem. That is what makes it a poem. Otherwise, something, if it is, if there is something which is coming to my mind, and if it is, quoted on paper on as it is basis, it will be just a prose. It will not be a poem. So as far as today's discussion is concerned, I will be focusing on poem. And so in one of my previous slides, I said that I will be focusing on text. So text, but of poems, not of stories. And this is just one example of one auto-generated poetry, and I have included the source. Now, just look at this. Who will say that this is not written by a poet? So I am not reading it, but this is just an example to give you a glimpse of how a poetry could be auto-generated using the computers. So this is another example. These are the same slides. These two slides are the same that I had used yesterday also. इश्क करने का शौक नहीं है, बस इतना समझ लो, देखिए किस कदर रोया है, कोई कहता है प्यार सजा बन जाता है. I mean, now who will say that this is not actually written by a poet? And इश्क करने का हक है तुम्हें, and so on and so forth. So just to give you a glimpse, particularly to those who had not attended yesterday's session, this is an example of auto-generated poetry. Now coming to the main area of today's discussion. So as far as today's discussion is concerned, this is the scope of today's discussion. So I will, as I said, that I will be focusing on natural language processing. I will be focusing on natural language understanding, which is one of its branches. And then I will be focusing on the text part, and then I will be focusing on the poetry part. And as far as the languages are concerned, languages of poetry could be Indian languages, or they could be foreign languages. Indian again could be Hindi, Gujarati, Punjabi, Marathi, could be Urdu, could be any other language. And when it comes to foreign languages, you can have English, French, Spanish, Italian, Russian, and so on. I mean, this is not, both of these lists are not exhaustive. And I have intentionally, just a moment, let me see. Yeah, I have intentionally included this exclamation mark with English, because English as such happens to be one of the two official languages of India, Hindi being the other one. But you can count it as a foreign language because at least it has been inherited in our country from the foreign land. So that way it can be treated as a foreign language, but I have intentionally put this exclamation mark because it can be counted both ways. And then we have NLG and NLU respectively for natural language generation and natural language understanding. So in the previous slide, I said what it is. And here I am in a way giving a possible application. So for NLG, you have the generation of language. For example, you have a lot of data stored in the database, and then you need to generate the language. And then you have AI chat boxes, as someone was discussing yesterday also. And then obviously you have Siri and Alexa, which basically generate the language. Though it is a simulation of artificial intelligence, it is not true artificial intelligence, as I discussed yesterday also. But yes, language generation for NLG. And when it comes to natural language understanding, you can have clustering, you can have classification, you can have translation, you can have anaphora resolution, you can have discourse analysis, you can have lexical analysis, you can have named entity recognition, you have summarization, and then for summarization also you have two types. You have abstractive summarization, you have extractive summarization, and then you can think of topic modeling, and so on and so forth. So there are you have stemming, you have lemmatization, which basically are used for more of downstream processing activities for NLP. But you have many of those activities which are included as part of natural language understanding. And then if you have to think about one of these applications, for example, I talked about clustering, I talked about classification, I talked about translation, and so on. One of those applications is classification. Classification basically means you have categories or classes And your system will make sure that whatever data you have, it is either categorized in the first category or the second category or the third category, and so on. So one typical example will be like designing an algorithm where you are showing the pictures of, let us say, cats and dogs to a machine. And then your machine, based on the features of those two animals, is able to identify whether it is a cat or whether it is a dog. So in that case, the classification that is used is, we call it binary classification, because you just have two classes. So bi means two. So for two classes, either it will go to first class or it will go to second class. And then accordingly, you have that concept misclassification also. Because if it was a dog and if it is correctly identified as a dog, it is good. But if it is identified as a cat, then it is misclassification. So this was one example of binary classification. Another example of, in fact, there are a number of examples. You can think of in the medical domain, based on some test, whether the patient has some disease or the patient is not having that disease. So again, yes and no type of question. So again, binary. And then you can think of an email which is coming to our inbox. So either it should land in the inbox or it should go in the spam folder. So you may call it spam, bulk, junk folder, whatever you call it. So either it is a desired mail or it is unsolicited. So again, yes or no. And so basically all of these are examples of cases where you have binary classification. And similarly, you have cases, for example, the type of ones that we have used today, where you have multiple classes. So instead of two, let me take example of the varieties of mangoes. So you have some 4 or 5 varieties, for example, of mangoes. So either it is Hafuz or it is Alfonso or it is some other category. So based on its physical characteristics, in fact, this is the concept of machine vision. But based on its characteristics, either it will go in category 1 or category 2 or category 3 or category 4 and so on. And you can always think of one catch-all category. Catch-all means if the system feels that it is not fit for any of previous 2, 3, 4, 5 n number of categories, then okay, this is the last category where if it is not fitting in any other category, it will go there. So that is called catch-all category. So typically it is said that if you have n categories, then you can plan for n+1. So last one will be like catch-all category. But again, it is not necessary. It just depends on the taste of the researcher. For example, in that cat dog example, it is not necessary that you need to have a third category also. So it is dependent on the researcher. Even for the cases where you have multiple categories, again, it depends on the taste of the researcher, whether you want to have n+1 or just n. In my case, I have considered n only. Okay. So I will be focusing on Indian language and it will be Punjabi. I will be focusing on NLU. So I will not be focusing on foreign languages. I will not be focusing on energy. I will be focusing on classification, not clustering, translation, etc. And as far as the classification is concerned, so classification of poetry, for example, can be done based on the language. For instance, as I said yesterday, that very famous song, which is I mean, the lyrics are written by Javed Akhtarji. No, this is La Mirada que dati Sarkadimi, which is basically Spanish. And then you have the Hindi continuation of the same song from Zindagi Na Milegi Dobara, the famous Senorita song. So one possibility of classification is that given a poem, you classify based on its language. So either it will be completely Spanish or it will be completely Hindi or it will be a mixture. If mixture, then mixture of which languages? So that is one possibility. The second possibility is to classify a poem based on its emotions, based on its sentiments. So when we talk about sentiments, you can think of the polarity concept. Polarity means either it can have positive polarity or negative polarity or neutral polarity. For instance, if I say this pen is good, so good indicates positive polarity. And if I say that it is bad, then it is negative polarity. But then you have some challenges also. For instance, if someone says it is not good, so not just based on that word good, you will be able to identify that the polarity is good, because then you will have to take care of not good. So again, it leads us to the concept of bigrams that I will be discussing in one of my next slides. Okay, so that was about polarity, and then you can have some neutral statement like this is my pen. So it is neutral. It is not having positive or negative polarity. Okay, then you have the structure of poem based on which you can classify it. So basically, this is the part that I had discussed in detail yesterday. In fact, the entire focus was on this part where I had used the concept of chand, or in English we call it meters, and then we had matrik chand, varnik chand, and muk chand, and so on. And then we used the concept of gun also. So basically, it is all based on the structure of poetry. And as I said yesterday, it is not so that you can think of this concept just for Hindi language, as we did yesterday. You can think for English also based on meters. For example, you have sonnet, you have haiku, something called haiku, which comes basically from Japan, and then many more types are there. And then another possible way of classification is based on the themes or based on the topics. So for instance, a given poetry could deal with romance, uh, ishq, mohabbat, pyar, and so on. It can deal with philosophy, it can deal with literature, it can deal with patriotism, it can deal with nature, mountains, clouds, and so on. So I will be discussing about all of these things in one of my next slides in detail. But here I am just trying to give you a possible direction that classification for poetry can be done based on the language, based on the emotions, based on the structure, or based on the themes. And obviously, you will find that there is some overlap, some overlap. So the line of demarcation among these categories is not clear cut. There is a little bit of fuzziness also. So for instance, if you talk about a theme which is based on romance, ishq, mohabbat, pyar, love, lust, erotic feelings, and so on. So in a way, it also overlaps with the emotions. I mean, you cannot think of emotions without love, for example. So there is a little bit of overlap also. So it just depends on the researcher, how you classify it. So there is a little bit of subjectivity. As far as today's discussion is concerned, I will be focusing on emotions and I will be focusing on themes also. Structure is something that I had focused on yesterday. Okay. So the typical methodology involved in in designing these type of systems is number one, pre-processing. Obviously, given the time constraints, I will not be going in all of these steps in details, but this is a brief overview. So the first step is obviously data collection, first of all. And data collection for languages of India, I mean, for Indian languages, it is a challenge because you do not have ready-made data available, data sets available. You do not have, it is typically called corpora. So singular is corpus. So basically it is like collection of documents, and plural is corpora. So you do not have ready-made corpora available when it comes to Indian languages. And that is why typically they are called low resource languages, not just in terms of data, in fact, but in terms of other tools also. For example, tools for stemming, tools for lemmatization, and so on. So that is challenge number one. And challenge number two, even if the data is available, you also have to take care to see that the metadata is also available. So metadata is data about data. And metadata means the year in which the poem was written, the author of the poem, and could be the ready-made available information like the number of lines, number of words, number of stanzas, the theme, and so on and so forth. So this is all about metadata. But typically in any NLP application, not just for poetry, in fact, even for prose also, the first step is data collection, and then you have pre-processing of that data, because in the phase of data collection, you do, and this assumes that you do not have ready-made data. And sometimes for the ready-made data also, you have to go for pre-processing. But if you are creating your own data sets, I mean, if you have primary data, then you need to make sure that it is consistent in the format, because generally what happens is you source it from multiple locations, from multiple venues. So you have to make sure that it is consistent, and before you feed it to a machine, it is in the same format. I mean, for machine, it should be irrelevant whether you have sourced it from website 1 or website 2, or portal 1 or portal 2. So this all goes with pre-processing, and how many steps of pre-processing will be used, and which of the steps of pre-processing will be used, it just depends. It just depends on the functionality that you need, on the end product that you are targeting, and on the sources of data also, and obviously the language also, because for languages like German, where you can have where you can have words as long as for up to 40 and more than 40 characters also, letters also. So it becomes really difficult. And for languages like Thai and Burmese, where you do not have clear-cut demarcation between the words, you do not have that concept of spaces. For example, if I write special symbol removal, for instance, I have put a space here, I have put a space here, and there is one space between P and W, and then between D and R. So it makes it a bit easy to identify the word boundaries. But otherwise, for many languages, it is very difficult. And talking about Chinese language, and for Japanese also to some extent, typically in olden days, they were written vertically. So as soon as you move from line 1 to line 2, you have that demarcation. From line to line 3, you have that demarcation. And they used to have those character sets, where each character set used to represent one full-fledged concept. And more than that, it was image-based. So, I mean, the point is that these type of cases do pose challenges in the pre-processing phase. Fortunately for Indian languages, including the English language also, we have clear-cut demarcation between the words, not just the words, even for the sentences and paragraphs and so on. Okay, so special symbol removal is one of the activities of pre-processing stage that we did as part of pre-processing the Punjabi poetry text. And special symbol means we had symbols like it is called Dandi, and this is called double Dandi. In Punjabi, it is called Dandi and double Dandi. You can call it Purna Viram if you have to use Hindi terminology, and double Purna Viram, which is very common and typically used in poetry in Indian languages. So removal of these two things, and then you have tokenization. So tokenization means you have one document, and so tokenization basically means finding the smaller part. So you have one document, and from that document, first you will find how many paragraphs are there. So the token here is the paragraph. In the next stage, so output of first stage becomes the input of the next stage. So from each paragraph, then you will find how many lines are there. And this is something which is applicable to stories also. This is something applicable to poems also, but I will be focusing more on poems. So because in poems, these sentences are comparatively clearer. One line, one sentence, second line, second sentence. Whereas in stories, you have that continuation, full stop, and then first sentence, full stop, and then continuation with the second sentence. So from paragraphs, so instead of paragraphs, I will be using the term stanzas, because this is for poetry. So how many stanzas are there? And given a stanza, how many lines are there? Given one line, how many words are there? So this all goes with tokenization. Specifically, when you find a word from a line, it is called word segmentation. And similarly, you can think of line segmentation and stanza segmentation also. But all of these activities are included as part of tokenization. And then the approach that was used by us was unigram approach. So in general, you have concept of something called n-gram. And value of n may be 1, maybe 2, maybe 3, and so on up to n. So if n equal to 1, it is called unigram. Uni means 1. And the meaning is like, so if you have the text as is visible on this slide, so you will have one word called special, you will have another word called symbol, you will have another word called removal. And typically these words are stored as bag of words. It is also called SOW, for set of words. So when I say bag of words, typically I mean to say that you have a bag and you are putting all of those words in that bag. So what is happening is the word order is lost. So if I say special symbol removal, you know that symbol is between special and removal. But when I use that bag format, you do not know the sequence. You do not know that special was followed by symbol or a symbol was preceded by special. It is just a bag. So you are putting everything, you are dumping everything in that bag. So again, there were many other approaches also, but this was the concept that we had used. It is called bag of words. And as far as this unigram thing is concerned, we have used n equal to 1, therefore it is unigram. You can also think of bigram. For example, when I was talking about sentiment analysis, when I was talking about this pen is not good. So not good, I will have to, for sentiment analysis, I will have to take bigrams so that the semantics are not lost. So I will have, for instance, if the sentence is this pen is not good, I will have this pen is not good. So bigrams, two words at a time. And if it is unigram, then I will have this as one word, pen as other word, is as other word, good as other word, not as other word. And similarly, then you can think of n equal to 3 for trigrams and tetragrams for n equal to 4, and then polygrams for the higher values. In one of my research works, I have used n equal to 1. This is one example, the one that I am discussing today. And in many other research works also, I have used n equal to 1. And I have used n equal to 2 and n equal to 3 also in a few of my research works where I had to, deal with the translation of idioms. And you should appreciate this because when it comes to idioms, you cannot treat each word of idiom individually. You need to maintain that sequence. For example, if I say, किसी का मुंह बंद करना, so मुंह बंद करना, I cannot treat karna as a separate word, band as a separate word, and move as a separate word. I will have to treat them all together as a phrase and in the same sequence. So that is one example where I have to use trigram, move band karna. So there are three words in the same sequence. And then you can think of the higher values of n also. So this was about unigrams and bag of word model. And then we remove the stop words. Stop words are those words which are irrelevant from the research perspective, from the statistical perspective. And there are many research works which prove that removal of stop words removes the efficiency. And let me give you an example from English first, then I will come to Hindi, and then I will come to Punjabi. So in English, if I say this is a presentation, so is not relevant from statistical perspective. A, it is not relevant from a statistical perspective or from research perspective. Similarly, you can think of this. You can think of, for, in, up, here, there. So all of these are stop words. So all the prepositions, all the articles, to, a, and, of, so all of them are irrelevant. So all of those words are removed. In English also. In Hindi, we have like ne, ki, ko, me, par, and so on. And in Punjabi, also similarly, we have stop words. Most of them are inherited from the format that we have in Hindi language, but then all of those stop words were removed. Again, like me, ko, and so on. Then we use the concept of TF IDF. So if time permits, later on I will go in detail also. But TF basically deals with term frequency, and IDF is inverse document frequency. Term frequency basically focuses on the weightage of a word for a given document. And IDF basically focuses on the weightage of a word in that entire corpus of documents. So you can see the TF is for one document, and IDF is for a given word, it is for the entire corpus, keeping into consideration all the documents. And then you take the product of these two terms. So that product is called TF IDF. And you can take TF individually also. For example, if you have one document and it says this is a sentence. So what is the frequency of this? 1. What is the frequency of is 1? So this is a simple frequency, the conventional approach. And then you can think of relative frequency also, which is generally used in case of TF. For example, if I say there is some document and it is having a total of 7 words, and this word comes one time, then its relative frequency will be 1/7. And similarly, for some other word like this is. So is second word, how many times it is coming. Let us say it is coming in that document. I am not talking about that sentence, I am talking about the entire document. So if it is coming 2 times, so I will say its relative frequency for TF is 2 by 7 and so on. Okay, so then we have the concept of k-fold cross-validation. It is a concept which is used for testing. So what happens is, suppose I have, let us say, there are 2 values. One is n and one is k. Uh, okay, so suppose n is 100. So that means the number of elements is 100. And suppose I take k equal to 10. So what it will do is, it will divide this set of 100 elements into 10 parts, where each part, or it is called set, for example, each set will consist of 10 elements. So 10 into 10 is 100. And then it will use set 1 for testing purpose and remaining 9 sets for training. So first it will train the system and then it will test it with S1. In second iteration, it will use S2 for testing and it will train the system with the remaining 9. So which 9? It will be S1 and S3 to S10. So second iteration. And then you will have third iteration where it will train the system with 9 sets except S3, and then it will use S3 for testing the system and so on. So that is k-fold cross validation. And this is the example where k was 10. So it becomes 10-fold cross validation. And then you have to, so basically when I say methodology, actually I have included pre-processing steps also. I have included the approach used for training and testing also, because when we have to talk about training and testing, we should first talk about training, because training comes first. First you train your system, then you test it. So then first I talked about methodology, including pre-processing. Before that I talked about data processing. And so data processing, pre-processing, and then you have testing, and then you have training, and then you have testing, and then you can find various measures to know what is the efficiency of the system. Now, there are various terms which are used interchangeably, you have the concept of precision, you have the concept of recall, you have the concept of sensitivity, you have the concept of accuracy, you have the concept of F1 score, or it is also called F1 value, F1 index, F1 measure, and so on. So again, see, there is no restriction, and it just depends on the taste of the researcher, which one of these to use. And obviously, to some extent, it may depend on the need of the system also. So the concept that we had used, in fact, we had used many of those concepts, but the one that I will be discussing in today's presentation will be accuracy. And if I have to go a bit in detail, you have, okay, fine. We will see if time permits. I will also go in detail as far as the discussion of the concept of confusion metrics is concerned, because accuracy, precision, recall, F1 value, all of these things are derived from the confusion metrics. Okay, so all of these things were done, and when we talked about accuracy, basically this was accuracy of classification, because this was a classification activity. So how many of the poems were classified correctly, and how many of them were not classified correctly? So basically that is the point. And obviously, if it is 100%, it means that all of the poems which were supposed to go to category 1 were classified as category 1. All of the poems which were supposed to go to category 2 were classified in category 2, and so on. So it gives 100% accuracy. But we have the concept of entropy. 100% efficiency is never possible in any system, and more so for these type of algorithms. I mean AI algorithms, which do most of the things in the background. So it remains like a black box, and then they just show the results on the screen, and then you can create various tables for the statistical analysis part. And why classification is important? Why did we go for classification? What is the application of classification? What is the benefit of it? See, number one, what happens is, suppose obviously it leads to better digitalization. That is the obvious benefit, number one. Number two, it helps in properly categorizing the things. It helps in properly organizing the things. And number three, it also helps in retrieving the things in a better way, in a more efficient way, and in a more user-friendly way. For instance, today, if I am interested in a poem from Punjabi language which deals with romance, so I do not have that structure available where I can dedicatedly find that type of poem. And obviously, you can do it through search engines like Google, Alta Vista, and others. But then they will just provide the data based on whatever corpus that they have. They do not have that structure. They do not have that categorization. So if we have that categorization, it will provide me with more accurate results. I mean, perhaps the first page of Google, if it is having, let us say, 100 records, then all of those 100 records will be very much relevant to what I am searching, instead of going through each record and seeing whether this is what I want or not. And basically, this is what is happening today with Google. Okay. Okay, so as I said that I will be talking about classification based on themes and classification based on emotions. So first I am talking about classification based on themes. And the features that I had used are textual features, which include lexical features, which include syntactic features, which include semantic features, and then I have also include poetic features, which include orthographic ones and the phonemic ones. See, there is again a little bit of, so to say, ambiguity as far as the use of these terms are concerned. For instance, orthographic features can also be counted as textual features. So as I said earlier also, it just depends on the taste of the researcher. And when we were writing another research paper on the same area, with hindsight, we believed that no, we should call it linguistic features. So that just depends. And for instance, in the same continuation, you can think of TF and IDF as statistical features also. But the important thing is that we basically classified a few features in one category and the other features in the other category. When I say lexical, I mean words. So words of a poem, that are my lexicons. And syntactic means each word of a poem considered with its part of speech. So it is called POS. Part of speech means noun, pronoun, adjective, verb. So here we just have words. Here we have words along with their parts of speech. And then semantic features means words along with its meaning. Semantics basically means meaning. For example, if I say bank, bank could be a river bank could be a financial institution as well. And if I say book, I may be using book as a verb, for example, to book a ticket. And I may be saying I am reading a book. So this is the difference. So that is where semantics help. And for semantics, we had used WordNet of Punjabi language, which was not designed by us, it was available. And for orthographic features, orthography means, in fact, there are a number of things that can be included as part of orthography. And typically, it is said that stylometric analysis makes use of many orthographic features, but our focus was not on stylometric analysis or author attribution, for example. So we focused on number of lines, number of words in a poem, number of stanzas, and then obviously the average number of lines and average number of stanzas for a given poem. And as far as phonemic features are concerned, we focused on, at least we tried to focus on rhyme. So in fact, you can call it rhyme also, as we did in the second work. So rhyme means either you can have something like a, A, and so on, which basically is monorhyme. So like pani, vani, nani, kani, and so on. And then we have the couplet where we had A, A, B, B. And then we have enclosed where we have A, B, B, A. And then we can think of triplet also, A, B, B, B. So based on the rhymes, they may be making similar sounds. So that was considered as part of phonemic features. These are the algorithms that we used. In fact, we used a Vika tool for experimenting, and it has some 40, 50 odd algorithms when it comes to classification. But these are the ones that we used. So this was the point where we took the first decision, why to use only these many? Because basically from the literature review, we found that for most of the research works which have focused on classification of poetry for languages, they have used mostly these type of algorithms. So that was the motivation, number one. Number two, when it comes to Indian languages, very less work has been done for poetry classification. And most of it has been done by my candidates only. I mean, if you talk about Hindi, if you talk about Punjabi, and then there was, if you talk about Marathi, then there is some work which was done for Bangla also earlier. And so these are the algorithms that we experimented with. And in order to start with our experiments from, let us say, 50 order algorithms, we chose these 10. And with a data set of 240 poems, 240 Punjabi poems, we experimented with all of these 10 algorithms. And based on the results that we obtained, we found that these four are performing better. Hyperpipes, HP, K nearest neighbor KNN, naive Bayes NB, and support vector machine, SVM. So we decided two things. Number one, we will increase our corpus size, and we will proceed with further experimentation with these four algorithms only. Now, we had only used lexical features when we were experimenting with these 10 algorithms. And we are already working for experimenting with all of these algorithms with the other features, for example, the syntactic ones and the semantic ones and so on. But basically, this helped us to shortlist the algorithms. So we proceeded with these four algorithms. So once we have decided about the algorithms, then we also, as I said, that we also increase the corpus size, because in order to generalize the results, you can't just say that I have experimented with 100, 200 poems, and then these are the results. But then you have that contradiction also, because it is very difficult to find data. It is very difficult to find, for instance, Punjabi poetry in the digital format. So that is what we did in this stage. And then we have hundreds of categories. So we tried to merge some categories, we tried to split some categories so that the poems which are almost related with each other can be clubbed together. But broadly, we settled down with these categories. So number one, nature, which deals with Kudrat. So you have Punjabi poems which are based on sun, mountains, rivers, and sunlight, morning, evening, and so on. So Kudrat. And then we had Punjabi poems which were related with festivals. For example, typically in northern India, we have Baisakhi and Basant, the seasons of flowers. So festivals as well as those celebrations. So all of these things were included as part of festival, including the festival of harvesting and so on. So all of poems from that category were included in festival. And then we have a linguistic category where the poems on Punjabi were included. So these were the poems which were written in Punjabi. I mean, they were scripted in, not scripted actually. That is a full-fledged different area. I will talk about it. but they were written in Punjabi, but they were written on Punjabi. For example, Punjabi mithi boli hai. So it praises Punjabi language itself in Punjabi language. So those were included here. And when I say scripted, again, there are two categories. Because Punjabi language can be scripted using Shamukhi, or Punjabi language can be scripted using Gurmukhi. So Shamukhi format was used earlier, and Gurmukhi format is mostly used. It has become like a de facto standard as on date. So most of the Punjabi as on date, it is scripted using Gurmukhi format. And if you go to some 70, 80 years back, then you will find Punjabi poetry scripted using Shamukhi as well. And we had focused on the Gurmukhi format only because we were not aware of the Shamukhi format. We were not acquainted with it. And then we focused on patriotic poems, Desh Bhakti, Desh Prem, and so on. Many poems written at the time of independence movement and so on. So all of those poems were included here. And then we had poems from the romantic category. So Ishq, Muhabbat, Pyar, Love, and so on. So all of those poems were included here. And then we had poems which are based on relations. So these could be a relation between a mother and a child, and her child could be father and daughter. So there were many Punjabi poems which are written in this category. Poems which show love of a brother and a sister. And so all of those poems which were based on the concept of relations were included here. And then we had philosophical poems. So philosophical poems included like those which talk about philosophy, which talk about life. मैं क्यों हूँ, मैं कहाँ हूँ, मैं क्या करूँ, and so on. So basically philosophical. And life क्या है, and so on. क्यों है. And then we had a category called spiritual, which basically deals with poems which are dedicated to God. So these included many of the poems from Sufi poets also. And though most of the poems in earlier days were written in Shamukhi script, but we were also able to find many poems which were scripted using Gurmukhi script. So all of those spiritual poems which are basically dealing with devotion, which are dealing with dedication to God and so on. So they were included in this category. And after creating these categories, availability of poems was already a challenge, as I said earlier also. We thought that we should merge these categories because they are quite similar. Many of them are quite similar in nature. So what we did was we clubbed these two categories, nature and festival, and we called it NAFE for NA from nature and FE from festival. And we called it, this is the point term, NAFE, our own category. And the total number of poems in this category then was 505. And similarly, we clubbed these two categories, linguistic and patriotic, and we called it LIPA, LI for linguistic and PA for patriotic. And the total number of poems was 400. Similarly, romantic and relational, we called it RORE. The total number of poems was 529. And it is quite obvious that, see, here the count is 529, here is 505, because for this category, we were able to find many poems which talk about love, and not only love between brother and sister, mother and her child, because the relational category is also clubbed here, but also the romantic ones. So 529. And then finally, we had many poems, as I said earlier also, that this is the category where we were able to find many poems which talk about philosophy and which talk about spiritualism. So all of those poems were included here. We called it PHSP, and the total number of poems here was 601. Now, if you take a total of all of these four categories, if I am able to recall it exactly, it was 2048 poems. And then we proceeded further with the experiments, and yes, so these were the results and the conclusions that we found. So we have 5 categories: lexical, syntactic, semantic, orthographic, and phonemic. And for each category, we have these 4 artificial intelligence algorithms that we tested. In fact, when we were performing these experiments, we had also used many other concepts that I am not discussing in this presentation, just to make sure that I am able to cover it within the allotted time. But we also experimented on the entire feature set, and then we also experimented on the partial feature set, reduced feature set. So we had used gain ratio to rank the tokens, and we tried to see if the reduced number of tokens helps in better categorization. But we found that the classification is working better when we are using all the tokens. And this is quite expected also logically, because had it been with the case, sorry, I am in a presentation. I am in a presentation. Because had it, sorry, because had it been with the stories, then perhaps with the reduced feature set, it could have given better performance. But with the poems, because a poem is already having limited number of words, and from that the length of poem is very small, and from limited number of words you remove some words because they are stop words, and then with whatever number of words that are left with you, if but this was just an experiment. In the field of research, you don't know what is going to happen. It is just a hypothesis that okay, it is expected to perform this way, but it may not. So we experimented with reduced feature set after ranking the tokens. So those tokens were ranked higher, which were believed to have more weightage, which were believed to have more relevance, which were believed to have more significance. And with the reduced feature set, we were not able to find better results. So we proceeded with the entire set of tokens. In fact, in our original research paper, we called it baseline research. So the results that I am showing here are basically the results on the entire token set. And for each of these 5 features, we have experimented with TF, term frequency, and TF-IDF. So now if you just have a look on these values, because on the first look, it will just look like, okay, there are many numbers. So let me just explain. So first I will emphasize on difference between TF and TF-IDF for all of these categories. So when you begin from here in the lexical category, you have 62 point something, 62, 40, 40, then you have 59, 59. So as such, there is no much difference between TF and TF-IDF for HP, KNN, and NP. But when it comes to SVM, that is support vector machine, you clearly have that difference of 72 and 66. So in a way, you can say that for lexical category, TF is performing better. And similarly for syntactic category, see 64, 46, again no change, 60, 60, and 72, 70. So again, SEM is performing better. So TF is performing better compared to TF-IDF. Similarly for semantic category also, here you have 64, so TF is better. 45, TF is much better. Again TF is better, again TF is better. For orthographic, you have same value, same value, same value, TF is better. And for phonemic category, you have same value, same, and here also TF is better. So the first conclusion is that if you have to experiment with the TF and TF-IDF, TF is better. So that is conclusion number 1. Term frequency gives better results. Okay, now we try to find which algorithm is performing better. So for HP, and now let us just compare the TF values only. So let us compare this value with this value and so on. So you have 62, 64, 64, 62, and so basically it is in 60s. Coming to KNN, you have 40, 46, you have 45, so basically in 40s. So in any case, between HP and KNN, HP is better. Then moving on to NB, you have 59, 60, 60. So basically in 50s and 60s. So again, HP is better among these 3, HP, KNN, and NB. And now moving on to SVM, you have 72, you have 72, you have 76, you have 71 and 71. So in 70s. So clearly you can say that between HP and KNN, HP is better. Between HP, KNN and NB, HP is better. Between HP and SVM, SVM is better. So number one, we found that TF performs better. Number two, we found that SVM performs, yes, SVM performs better. And now let us see which feature set is performing better. So now we will have to see it vertically, and let us focus on TF part only. So for lexical, we have in this column, lexical and TF, we have 62, 40, 59, 72. For syntactic TF, we have 64, 46, 60, 72. For semantic, we have 64, 45, 60, and 76, and so on. So we calculated the average of all of these values, and okay, let me change the color because it looks similar. So let us say if this is the color. So average of these values, average of these values, and so on. And we found that semantic is giving the best performance. So that is conclusion number 3, that semantic category is giving the better results. So based on our experiments, we found that term frequency gives better results when it comes to Punjabi poetry, and obviously it may be different for some other language. It may be different. Obviously, to be honest, if you increase the corpus size, it may differ. So it is subject to that condition. But based on these experiments, based on the data set that we used, we found that term frequency is performing better, SVM is performing better, and semantic is performing better. And let us proceed to next now. So this is just the graphical representation of what we discussed in the previous slide. So here you can see so again, similar to the previous slide, on first look, this will look just like you have some pillars. But technically speaking, just see the length of this set of pillars, this set of pillars, and the fourth one. You will immediately come to know that SVM is performing the best, and KNN is performing the worst because it is having the length of pillars which is minimum, the height of pillars which is minimum. So you can see that SVM ranked number 1, HP ranked number 2, naive Bayes ranked number 3, and K nearest neighbor ranked number 4. And then if you have a look based on the features, and these are the textual features only, the ones that we call textual features, lexical, syntactic, and semantic. So almost syntactic and semantic are at the same level. Here also they are slightly at the same level. Here also for NB they are at the same level. And for SVM, semantic seems to perform well. And overall, if you see the height of this column is less. Here also it is less, here also it is slightly less, and here also it is slightly less, and it deals with lexical. So in a way, lexical features did not give us the good results. And syntactic performed well, and semantic performed the best, because semantic here also is performing well, here also it is performing well, and here also it is performing well. So basically, this is the graphical representation of the data that we have seen in the previous slide. But this was all about textual features. Coming to the poetic features, or at least the ones that we called poetic. So we had comparison between orthographic and phonemic, almost at the same level, almost at the same level, almost at the same level. And for KNN, we found that phonemic is working much better. And overall, if you see the average height of pillars here, average height of pillars here, and average height of pillars here, SVM again outperformed all other 3 machine learning algorithms. And now if you have to compare between textual and poetic, so basically this third graph is average of this graph 1 and graph 2, and you get this third graph. So the first thing that you can observe is that KNN performed worst, SVM performed the best, And as far as the features are concerned, so you can see that textual here it is having more height, here also it is more height, and here also it is more height. On an average, though it is less here, on an average you can say that textual performed well. So this was all about the results and conclusions of the first experiment. And one last part, because we found that SVM is performing well, we found that TF is performing well compared to IDF, and SVM compared to naive Bayes, hyperpipes, and the third algorithm, the KNN, K nearest neighbor. We were also interested in finding which category is performing better. So NAFE, you can see it is 85, 85, 87, 85. So in 80 is LIPA 90, 90, 91, and so on. RORE 81, 82, 85. So on an average in 80s only. And PHSP 79, 79, 80s. So LIPA, you can see that the average of this row will be highest. So LIPA was the category that we found that it is performing the best. And between RORE and PHSP, you can see that PHSP was the category which performed the worst. So these were the results based on the experiment number 1. And now I move on to experiment number 2. So here we did classification of Punjabi poetry based on emotions. And for emotions, we considered, what are those emotions? We considered the concept of Navrasa. And which are those Navrasa and how many poems were there? I will be discussing in the next slide. The features that we considered for this classification were linguistic features, lexical and syntactic, and as I said earlier also, that instead of linguistic, you can call it textual features also. And then poetic features, rhyme, which is nothing but the phonemic feature. And here we did this experiment with poem title. We thought that let us consider poem title as one feature, and let us see if it has any influence on the classification activity. And the results were quite encouraging actually. And we experimented just with two algorithms. This was a smaller experiment, NB and SVM. And to some extent, this was also based on our partial results that we obtained from the previous experiment that SVM is performing better. And NB, it is like de facto standard for this type of experiments. And we used one more concept called Place-Kappa index. And what is it? Let me just explain. See, what happened here was, as I said earlier, we used the concept of emotions. And for using the concept of emotions, we had those 9 rasas. So it is called Navaras. And we have Shingar ras. So these were the emotions that we used. Now, we had Shingar ras, Karuna ras, Hasya ras, Raudra ras, Veer ras, Bhoot ras, Bhyanak ras, and so on. And we thought that compared to the classification that we are doing, as we did in our experiment number 1, it will be better if we are asking some other person to classify it for us. And the number of poems that we used here was 980 and almost 1000, you can say. And these 1000 poems were given to one person who was expert in Punjabi language. Like Punjabi was his native language, and we called that person because we wanted to get our data annotated. So we called that person A1, and then we had A2, and then we had A3. So we had 3 annotators. So after the annotation of poems was done by these 3 annotators, and what do we mean by annotation? Annotation means given a poem, that annotator will tell us whether it belongs to Ras 1 or 2 or 3 or 4 or 5. That means whether it belongs to Hasya category, whether it belongs to Raudra category, whether it belongs to Vibhats category, whether it belongs to Shingar category, and so on. So after getting the data, we used Place-Kappa index, which is basically used to calculate inter-annotator agreement. And the inter-annotator agreement that we obtained through the use of Place-Kappa index was 0.78. And this is the interpretation of Flay's Kappa index. If the range is less than 0, then the agreement between the annotators or among the annotators is very poor. So you cannot accept that result. So it is poor agreement. Then from 0.01 to zero point 0.2, you have slight agreement, and then fair, then moderate. And our value of 0.78 fell in this range, which is a substantial agreement. And to some extent, best also, because you have some subjectivity when you are doing this type of annotation. Because one person may feel that it is in the Shingar category, other person may feel that no, it is in the let us say so something which is very close to Shingar could be Hasya category. Someone will believe that a given poem falls in Adbhut category. Someone may feel that no, it is not in Adbhut category. It is in let us say Shingar category only. So 100% efficiency even we were not expecting, but the inter-annotator agreement of 0.78 was quite good. So we proceeded further, and these are the those 9 rasas that I was talking about. So we have Karuna ras, Shingar ras, and so on. And you might observe that I said while discussing in the previous slide that we had a total of 980 poems, but here we have 948 only. It is so because there were 32 poems that we found, and the annotators in fact found that they were like very awkward, and it does not seemed appropriate to classify them in any of these categories. So had we considered the 10th category, like the catch-all one that I was discussing, so they could have been classified there, but they were the exceptional cases. They were not fitting in any one category. Or the annotators were confused, like, should I put it in this category or that category? It seems to go in multiple categories. So we simply discarded them for the experimental purpose. And Karuna means pity. And Shingar means the poems basically which are dealing with love. And Hasya means poems dealing with comedy, dealing with amusing thoughts. And Raudra means those which are dealing with annoying, irritating, anger, disgust. Not disgust, because disgust will go in Vibhats. Veer will include poems which are dealing with heroic activities, bravery. So from our understanding of previous categories, mostly the patriotic poems go in this category. Bhayanak means which lead to horror, fear, frightening, and so on. Bibhats means disgusting. So something that you feel like, oh, this is that bad. So the feeling that we get, for instance, if someone is spitting, so that is Vibhats. And Adbhut is like, wow. So wondered, surprised, amazed. So Adbhut, and Shanti means peace, Shantras. And this is the number of poems in each category, giving us a total of 948. So here we experimented with approximately 1000 poems. In the previous case, the number of poems was 2048, so approximately 2000. And there we experimented with first we had a look on 50 algorithms. Then we decided that we will proceed with 10, and we experimented with 10, and we found that 4 are performing better. And then we proceeded with those 4, and we found that SVM is better. Here we had experimented with only 2 algorithms, NB and SVM, and these were the results. So this is NB, naive Bayes, this is sport vector machine. These are the linguistic features, and these are the poetic features. So when I say linguistic, I mean lexical ones, syntactic ones, and for poetic features, we have rhyme, and we have poem title. And if you analyze this data, you will come to see that okay, what we can do is we can just see the averages. But roughly, if you have a look on this data, see it is 60, 79, 59, 64, 75, and so on. And I am just giving you a comparison between lexical features and syntactic features. So 60 is better than 59, 79 is better than 76, 59 almost equal again, almost equal. Again, lexical is better. Again, lexical is better. Again, here syntactic is better slightly, and again lexical is better. So roughly for linguistic features, you can see that lexical features are performing better. And obviously, this is just interpretation based on this data, and otherwise you can analyze it based on their averages and graphical analysis too. And if you now have a comparison for the support vector machine algorithm and comparison of linguistic features, lexical and syntactic. See, 61 is better, 77 is better, this is better, again, this is better, again, almost equal, better, again, not better, not much better, not much better. But on an average, again, it will be almost, I think, lexical will be found to perform better compared to syntactic ones. Similarly, you can compare rhythm and poetry also. 63, 64, sorry, 65, 74 is almost equal, 58, 60. So again, this is better. Again, this is better. This is better with 86, much better, 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 and better. So for naive-Bayes algorithm, PT is performing better. So basically, PT is poem title, and this is something that we had, honestly speaking, not expected, because we thought that poem title it is having just a few words. So will it be able to help in better classification? But we found that actually it is performing well. And the possible rationale behind it could be, the possible reasoning, the possible logic behind it could be, because whenever a poet decides a title for a poetry, then the poet also tries to make sure that the gist of the poem, the essence of the poem is included in the title. So perhaps this was the reason, considering poem title provided us with better results. And this is so for SVM also. See, instead of 63 here, it is 67. Again, slightly better, much better. Here also 85, 76 instead of 71, 64 against 63, 70 against 68, 67 against 64. So here also PT is performing much better. So these were the results that we found based on our second experiment. And this is the graphical representation of the results that I had shown in the previous slide. Now here, if you see, in fact, it is better interpretable through this graph. Now, first, let us compare NB and SVM. So NB and SVM means we will have to look for black, red, and for SVM, we will have to look for green and blue. So if you have a look at this graph, you will find that green blue is ranking higher. See, green here, here, green, blue, blue, green. So compared to black and red, you will find that green blue is performing better. So it provides us the conclusion that SVM performed better here also. So in general, now we can say that SVM performs quite well when it comes to classification of Punjabi poetry. And for that matter, one can experiment with poetry of other languages also. So between NB and SVM, SVM is better. And now if you have to see whether linguistic features perform better or the poetic features. So now we will compare black and blue with red and green. So if you see here, black and red are almost towards bottom. Black, red, here also black, red, here also red is there, here black is there, black is there, and black is here, red is here. So obviously, I am just making average estimation. So you can say that between the which comparison did we make? For NB and SVM, SVM is better. And for linguistics, we will have to make the comparison between black and blue. So I think we did it the other way. It should have been with black and blue. So black and blue, almost they are equal here, black and blue. So you can see that red and green are performing better. And in fact, it sometimes becomes difficult to interpret graphs like this. So you can always go to the averages And basically for our interpretation, what we did was we found the averages using the Excel sheet. And we concluded that poetic features, if I am able to recall it exactly, poetic features were found to perform better. And if you have to see this from point of view of categories, you can see that here it is at the top. So Veer category was performing the best, and you can say that this Hasya category and even the Vibhas category, they were not performing that well. And this Veer was performing quite well. And then you had this Shingar category, which was performing quite well. You can say that it is at the second number. And on x-axis, we have used these 9 rasas or 9 sentiments, as we called. And on the x-axis, we use the concept of accuracy. And as I said earlier also, we have the concept of confusion matrix. So you have the two positives and two negatives and false positives and false negatives. So you have actual values, you have predicted values, and then you have actually positive value and actually negative value, and then you have predicted positive value, you have predicted negative value, and then you get a matrix like this. And then based on the values that you get at this position, at these 4 positions, so these are true positives. So positives which were supposed to be classified as positive, they were classified as positive. So this is something which is welcome. And these are true negatives. So negatives which were expected to be classified as negatives were actually classified as negatives. And then you have false positives, and then you have false negatives. So basically, when you calculate recall, it is a ratio of this value with summation of this value. Similarly, when you calculate precision, it is basically this value divided by summation of this value. And accuracy is summation of TP and TN divided by the total number of values. That means the total population. And based on precision and recall, you can also calculate something called F1 score. So it is 2PR divided by P plus R, where P is precision and R is recall. So basically F1 score is generally used where you have to strike a balance between precision and recall. Generally what happens is if you try to make sure that one quantity is giving you better results, then the other quantity, the values for the other quantity start deteriorating. So it is like a trade-off, whether to go for this or whether to go for that. And then you have to choose one. So this was all about confusion matrix, and confusion matrix concept is something which is used not just for this classification for this particular activity. This is the concept that can be used and is actually used for the classification of any text or in general for any type of classification, not just text, not just Punjabi, not just poetry. And the example that I had considered here basically talked about 2 categories. I mean, classification between 2 categories, positives and negatives. In our case, it was like category 1, category 2, category 3, and so on. So something which was supposed to be classified as category 2, if it is classified, suppose something is supposed to be classified in category 1, and if it is classified in category 1, then the intersection of this row and this column provides us TP. And then anything which was supposed to be classified in category 2, but the system classified it in category 1 will go here and then here. So they will not be too positive. So basically these are the values which actually decrease the performance. So ideally what we expect is C1 against C1 and then some value here C2 against C2 and the C3 against C3. So typically it is the diagonal which gives us the best results. So because diagonal will indicate that these are the values which were supposed to be classified as not values, could be entities, could be poems, could be dogs, could be anything. They were supposed to be classified as C1 and they were actually classified as C1. Supposed to be classified as C2 and they were actually classified as C2, and so on. So if all of those values are coming in the diagonals, then it is the best case. But as I said earlier also, in any system, 100% efficiency is not possible. So there will be some values which will be here, which will be here, which will be here. So what about those values which are coming here? So basically it will indicate that you had some, for example, in our case, you had some poetry which were classified by the system as belonging to C2 category, whereas actually they were not belonging to C2 category. So those values will be coming here. Similarly, you will have some values here. So those will be the number of poetries which our system said that they are actually belonging to category 3, but they actually did not belong to category 3, and so on. So that's it from my side. The platform is open for questions, if any. And if you have any questions as far as these results are concerned, I will have to go to the. So is my screen visible? The Excel sheet or no?
Yes, sir.
Are you able to see this Excel sheet?
We can see the result and conclusion page right now.
Wait. Okay, wait. In that case, I will have to stop sharing, and then I will have to share this, and then I will say share. Now, are you able to see the Excel sheet?
Yes, sir. Yes, sir. Now we can see the Excel sheet. Thank you.
Because I felt that while I was talking about the interpretation from that graph, the things were not that clear. Because in the graphical format, so it becomes sometimes difficult to interpret. So if you are able to see the Excel sheet now.
Yes, sir.
Just a moment, it says it is not responding. Okay, so what I will do is I will just find average of values here. So are you able to see this average, 64.68?
Yes, sir, we can.
So now what I will do is I will find average of all of these columns. So now you can have a better idea which one is performing better. And so for instance, for naive-Bayes algorithm, the linguistic features and this lexical one, it is giving 64.68, this is giving 64.31. So obviously this one is better, 64.68. And when it comes to the lexical and syntactic features of SVM, 65.80 and 65.39. So again, this one is better, 65.80, isn't it? And if you compare 4.68 with 65.80, then this one is better, 65.80. Isn't it? 64.68 and 65.80. So this one is better. So one conclusion is that lexical features are performing better compared to syntactic features. And when it comes to NB, the average of these four values is 61.25. And so it is 61.25. And for SVM, it is 64. So you can say that SVM is performing better. So that could be the second conclusion. And when it comes to comparison between poetic features, here it is 61.23, 64.10. So poem title is performing better for naive-Bayes. And for SVM, 64.89 and 67.89. So if you compare these two values, so if the things are not that clear, let me just color it. So in these two values, PT is performing better, poem title. And if you compare these two values, again PT is performing better, isn't it, with 67. And now what I do is I will just compare the PTs of these two. So it will give the best of the best. So 64 and 67. So again, SVM is performing better. So our conclusion could be that PT is performing better as far as poetic features are concerned. So this is the conclusion. So now I think that the things are much clearer compared to that graph. So over to you. If you have, if at all you have any questions, most welcome.
Thank
So,
you.
so
Yes,
while
yes, please go on.
sorry. So while I was in the presentation, I was not monitoring the chat box. So let me just go to the chat box to see if at all there are any questions. No, I am not able to find any. Okay, over to you.
Okay. Thank you so much, Professor Saini. It was very inclusive, very exhaustive presentation where you spoke about the methodology, how the problems faced while collecting primary data. Because in Indian languages, you're absolutely right that collecting data is a task because we don't have a lot of documentation done already in the regional languages and especially poetry. Um, sir, one question I wanted to ask from my end was that you have used the nine rasas, the navras, to categorize this. So, what other categories could be used for poetry in maybe Hindi language or Urdu language? If you could suggest any pointers and which direction to look for, or do we have to create our own categories? Is that a possibility? So, could you throw some light on that, please?
Yeah, definitely. So your question consists of multiple sub-questions. Let me try to answer them one by one. When we thought that we will try to classify the Punjabi poetry based on the emotions, we started to think in terms of what could be the possible emotion. So naturally, the first thing that came to our mind was like love, because that is the category which is the favorite of the poets. So then we thought that okay, we can have something which is related with patriotism. But then I had this discussion with my research candidate also, and we found that most of the poems which are dealing with the patriotic category, they can actually be classified as Veer Ras.
Virus.
Veer. So I said that instead of finding out with the emotions on our own, why not use the concept of existing Navarasa? But having said so, let me also add that this is not a restriction. We just made use of those existing nine categories. But if you have to think of some other emotions, if you have to think of some other sentiments, if you have to think of some other categories, one possibility could be, because see what happens if you have to find data for those nine categories. Naturally, if you have 1,000 poems, then roughly they get divided among those nine categories. So each category roughly getting 100. And you can't have your data set like first category having 100 and the second category having only two, third category having again
Huh.
100, because then it will make the distribution of data biased. So then it will have its impact on the machine learning algorithms also. So that was not our intention, to make it biased. So instead of using this concept of Navrasa, nine emotions and nine sentiments, one possibility that to the best of my knowledge has not been experimented yet, and it is still open research area, could be to just think of two categories, and it will lead to binary classification. So like it could be love and non-love. And I believe that, for instance, my null hypothesis will be that it will give better results, because you will have clear cut demarcation between the category which is dealing with words which are related with love and the otherwise. And what you can do is, the other possibility is, for instance, we talked about those four categories: NAFE, LIPA, RORE, PHSP. And we found that, so if you see those results which are based on the specific classification for a particular category, we found that the poetries which are related with PHSP, philosophy and spiritual,
And
they are,
spiritual, yeah.
yeah, they are actually most of the time misclassified in the RORE category, which is for romance and relations. And this is natural, because what happens is when a poet says, when a poet talks about spiritualism, the poet talks about the relation with the God. So this system is interpreting as if it is in the relational category. So one possibility is to merge that PHSP and RORE categories together. That is also one possibility. But see, honestly speaking, from research point of view, I would not say that just because we want to get 100% results, therefore we are merging it. No, we are not doing so. In fact, my research candidate always used to say, "Sir, we are not getting 100% results." And I always used to say, because we are not getting 100% results, that is why we are contributing to the research committee. Our target is not to get 100% results, but our target is to find that based on, see, there is a lot of subjectivity. We have experimented
Lot
just
of
with 5 features. You can think of more features. You can think of combinations of these features. For instance, in our experiment one, we did not make use of poetry title. In our experiment two, we made the use of poetry title and we found that it is performing better compared to the phonemic features. So what could be done is you can experiment with, and in our experiment too, we had used only 2 algorithms. So what can be done is you can experiment with 4 algorithms using poetry title that has not been tested. Or what you can do is you can test those 10 algorithms that I had shown in one of my slides. Because
Yes.
in order to shortlist those 10 algorithms, I mean from 10 we came to 4. We had just experimented with lexical features. We have not experimented with semantic features, which later on performed better when we experimented with those 4 algorithms. So it might happen that when you are experimenting with semantic features for those 10 algorithms, instead of these 4, you might get some other combination. So there are a
Yes.
lot of permutations and combinations which are possible. And as I said, we found that TF is performing better compared to TF-IDF. But
Yeah.
we have not experimented with the TF-IDF when we were experimenting with those 10 algorithms. So in fact, it is a contradiction because it might happen that if you are using, because now we have that result. So now if you experiment with the poetry title, now if you are experimenting with the semantic features, which we found to perform better. And now if you are experimenting with syntactic features, let us see these 3.
Mm.
And with
Mm.
those 10 algorithms, and with those merger of categories, and with the merger of those emotions also, you will have a full-fledged new experiment. Are you getting this? And then you can
Yes.
think of a
Yes.
different language also. Instead of Punjabi, then you can think of a different language. So it is a full-fledged new research area. I mean, one can be already PhD in this area because you have so many of combinations.
So
And
many.
as I said that I had also, I mean, me and my candidate, we had also experimented with reduced token set. So we had used gain ratio. So instead of gain ratio, you can use some other ranking algorithm to rank the features. So that may give different results. So again, you will have a different combination. So there are a lot of options. So if that answers your question as far as the possible research directions and pointers are concerned.
No, certainly, sir. Thank you so much for that answer. Because, sir, it is a very interesting and it is very useful because, as we are a lot in this Department of Literature. And we need more data. We need data which is categorized so that it's more accessible. Because eventually, all the work, with computational linguistics is, aimed at making literature more accessible to people. So it's very important what we're looking for when we go to Google, we look for keywords, we just search and something shows up. So we are depending on the accuracy of the system, of the algorithm to give us the result that we want to see. Thank you so much. And we have sir a question in the chat box.
Yeah, just a moment. And in addition to that, it reminds me of 2 more things also. See,
Yes.
yesterday I discussed about the structure of Hindi poems. But
Yes.
no experimentation has been done for a structure of Punjabi poems, for example, or for that matter, structure of Urdu poems, could be shairi, could be ghazals. So that is still untouched area. So that is also a possible direction. So while you were talking about it, it reminded me of 2 points. So this was point number 1, structure, and I forgot. There was one more point that came to my mind. Okay, so if at all there are any questions in the
Sir,
chat.
yes, sir. There is one question from Sumita Sharma in the chat box. I'll just read it out.
This is super
What?
interesting. No, I will go through it, no problem. This is
Yeah,
super
sure.
interesting, for we started off with each 2 in case of Urdu in our ongoing keyword project at JMI. Oh, yes, that's good. That's excellent. And okay, what tools can be used to detect figures of speech? Oh my God. Again, I was expecting this. See, when it comes to figures of speech, okay, first let me go through the exact question. What tools can be used to detect figures of speech like metaphor or other literary devices like assonance and consonance in corpus of poetry? Okay, fine. See, to the best of my knowledge, I don't think that there are ready-made tools which can be used for detecting figures of speech. And if at all they are there, even if they are there, they are not performing that well. And you should not be surprised because this is my area. I have been working in this area since 15 years, ever since I was, started working in this area. So my research candidates are already working in this area. So down the line, after 2 years or 3 years, you will find some excellent tools, I can say, which are available on net, and they will be able to not only find figures of speech, but they will also be able to give the details of figures of speech. We have already started working on it, and we have also got some good results also, quite encouraging and promising results. But at the same time, this area is very, very challenging because, see, figures of speech or alankar, as we call them in Hindi, are of multiple types. You have that hierarchical structure. So, for example, if you have anupras, then you have multiple types in anupras. In English, we call it alliteration. There are some figures of speech which can be easily identified. For example, repetition. How are you? So how is a word which is repeated, so it can be easily identified. And even alliteration can be easily identified. For example, there is one poem by Maithili Sengupta, Charu Chandra ki Chanchal Kirne. So cha, it can be easily identified. But when it comes to simile, when it comes to metaphor, even simile can be identified to some extent, because in any case you will have words like jaise, so direct comparison. So in English, we will say like or as is used. So that can also be identified. But when it comes to the advanced concepts, for example, metaphor, when it comes to synecdoche, when it comes to metonymy, it's not that easy to identify. When it comes to euphemism, when it comes to hyperbole, when it comes to yamakalankar in Hindi, or you have pan in English, because same word is having two meanings. So you need to identify the context first. Unless you know the context, and unless you know the context correctly, it will completely give you a different meaning. So the figure of speech may be wrong. So these are the challenges that we are facing. But yes, it is a very interesting area, and we are also working in that area. Yeah.
All right, sir. So I don't think we have any more questions for now. And I would just like to.
Most of my discussion today was focused on the technical aspect, and I intentionally did so because yesterday, I tried to create that platform. So
Yes,
for
yes.
those who have attended yesterday's session and today's session, also today's session will be like complementing and supplementing what we discussed yesterday, because this was more on the technical side. But I thought that, and that is why in the title also, when Professor Nishat has contacted me a few months back, I designed the title this way because I knew that I will be having two sessions. So I thought that in the first one, there will be platform, backbone should be there. And then in the second one, I will be focusing on artificial intelligence, where actually technology is coming into picture. And having said so, let me also add that as of now, I have not discussed anything about deep learning. I haven't discussed anything about BERT. I haven't discussed anything about GLOVE. I haven't discussed anything about word2vec. And I haven't discussed anything about transformers. I haven't discussed anything about transfer learning. So what is happening so these are all deep learning concepts. So what is happening for transfer learning is like you design one algorithm for a particular language. Let us say, for instance, we did some work for Punjabi. And now you want to apply this same or similar concepts, let us say for Hindi language. And you say, and as you said also, that the data which is available for Hindi language is limited. In fact, for Hindi, it is not that bad, but let us assume that for some languages, it is limited. So in transfer learning, what we do is we apply the concepts learned by the algorithm on one language to a similar language. So even though the data is less, the same concepts could be applied. And this is more critical, this is more relevant, this is more important for languages like the ones we are discussing. We talked about Hindi, we talked about Punjabi, we talked about Marathi. In fact, we haven't talked about, but my candidates are working in Marathi also, and then Tamil and Telugu. Because all of these languages directly or indirectly share some common characteristics. So something that you have derived for one language can be very well applied to other languages. So for instance, if I say that based on our multiple experiments, we have concluded that STM is performing better and poetry title is having a big role to play as far as the classification of Punjabi poetry is concerned. So I will not say that I can blindly apply those concepts, but I will say that to a great extent, I can apply those concepts to any other language, for example, Hindi. Because they are relatives. And why I am emphasizing they are relatives? Because this was the reason why I started my discussion yesterday also and today also. I started my discussion with the concept of language families. So who is my closest match? My closest match is my sibling, my brother or my sister. And then it comes to my parent. And then it comes to the siblings of my parents and then their children. So if these concepts are applicable to me as a human being, then these concepts are applicable also to languages because they are also having their families. So, okay, that's it. I mean, this is something you can just keep on talking. That's it from my side. Over to you. Thank you.
No, sir, I think you are. Thank you so much again for your input. I think it's very important to. So once you have developed this algorithm and you have worked, so much, so hard on developing this, so it would be wise to actually use it. And this Navras category, especially, is quite exhaustive. It's not at all. It doesn't leave out a lot. It's quite inclusive. So in that sense, since we do use a lot of Western algorithms to our use, why not, have something which is developed here, developed for this language family, especially in the Indian context, and it would be wonderful. And we have some thank you comments from the department and Sumita for you, sir. Please, if you can go through them, and thank you so much. Would like to thank again Professor Nishad Zadi ma'am and the Department of English and um, you for being with us and sharing your research, your years of research with us. And we look forward to having you again at Jamia at another conference. And I'm sure a lot of students will also want to keep in touch with you, over email in the future, so you can be with us and guide us, because this is a very new concept for us. I have to be honest, sir. We have not worked in digital humanities before in the department. So this is sort of new, and a lot of us are quite excited to be here. Thank you so much.
Most welcome. And all of those who are posting in the chat box that you might be interested in contacting me later on, you are more than welcome. I will be more than happy to help you. Thank you. Thank you.
Thank you. Thank you, sir. Good afternoon.